Next, let's study week 5 GARCH model, and then this PDF file. Uh, this one is yes, and then yes, this one yes. Okay, so more volatility models in the textbook. Okay, again in R we shall use F GARCH as the most volatile models, but I shall discuss the package GARCH later, which can be used as MacGarch, MIGarch, eGarch model. Then let's discuss this variants of GARCH model. They are quite useful. GARCH M model is very useful in my personal experience. Very useful to Ivor models. Okay. So RT, let's say we have mu constant sum plus C sigma T. So sigma T affects mu. Okay. And then we have shock. And then shock is sigma T epsilon T, and sigma square is this part it is what? It is GARCH 1 model, where C refers to the risk premium, which is expected to be positive. So here we are assuming that in this model we are assuming that return is possibly positive function of this particular measure of risk, which is variance, square of the volatility. So if we have a high volatility, assuming C is positive, when volatility is high, we expect R is high. When it's empirical question whether C is higher or not. Okay, where C is referred again the risk premium. Risk premium means per variance. Okay, per variance, which is pretty positive. Example, or GARCH M11M model for the monthly excess return at 500 from January 26 to December 21. The fitted model here is very interesting. Okay, so RT monthly return is positive function of its monthly volatility, which is estimated is this one. But thing is the standard error of risk premium is this one. So the estimate is not statistically significant. This is not statistically significant, but who knows? It may significant in some stock, possibly some stock, or possibly well some subset of other classes such as commodities or bond. So it could be a nice exercise to check in which kind of asset or stocks or others maybe we have some positive risk premium in this way. Okay, so this is sample code. The R script GARCH M is relatively slow. It is computing intensity to use of recursive route in evaluating likelihood function. Okay, well it means this is a bit hard because well depending on modeling this, we define AT. But process of AT determines sigma T. Okay, so we have iteration. We need model of this one, then depend on this one. So chicken and egg problem. So we should start from somewhere, and then we have to iterate. Okay. Now eGarch model. The idea concept of eGarch model is useful. It is very useful model. In practice, it is easier to use than the T-Garch model. Asymmetry in response to past positive and negative return. Okay, so we have Z, which is function of epsilon t, and we have some sensitive. Okay, it is increasing function of epsilon, but then we have epsilon et, absolute value of epsilon t minus expected epsilon t. So it makes depend on whether epsilon is positive or negative. Okay, depending on whether epsilon is well in the previous GARCH model, positive shock, negative shock has the same effect. It is all squared, but now we measure the gap. Okay, here it is not squared. Okay, we have this term. Okay, you have this term. Therefore, it makes different whether it is positive or negative. To see the asymmetry between positive shock and negative shock, and G epsilon, we write it as G epsilon is zeta plus gamma epsilon, and theta minus gamma when epsilon is positive, epsilon negative. So indeed here, therefore, this gamma term captures the asymmetric effect. Okay, so this is very important. We know volatility is particularly high when there is negative shock in stock market. For example, in the stock market. Okay. An GARCH MS model is something like the GARCH MS model is a T is sigma T epsilon T and two model sigma T. Actually, we model log of sigma T. Okay, and then you have something like this. If you have something like this, some feature of the GARCH models, we use log transformation to reflect the positive constraint. Actually, GARCH model is in some sense easier to estimate the GARCH and as much responses. Consider an GARCH 1-1 model, which is looks like this one. Okay, GARCH 1-1 model. And then under normality, expected value of absolute value. Epsilon is simple root 2 over pi. And the model becomes something like this: 1 minus alpha backshift operator log sigma t is alpha star plus theta plus gamma epsilon t minus 1 when epsilon t minus positive, and negative it is alpha star plus theta minus gamma epsilon t minus 1 where alpha star is some sort of this constant. This is nonlinear function similar to that of threshold AR model of Tong. Specifically, we have this sigma depending on when it is positive or negative. So, well, sigma is different when it's positive or negative. The coefficient theta plus gamma or theta minus gamma shows asymmetry in response to positive and negative AT minus 1 shock. The model is therefore nonlinear if theta is not 0. Thus, theta is referred as the leverage parameter. Okay, leverage parameter, that's important. Okay, focus on function g epsilon t minus 1. The leverage parameter theta shows the effect of sine of a t minus 1, whereas gamma denotes the marginal effect. Okay, for more information, we can see Nelson. Another example: monthly log return of IBM stock for January, and then January 1926 to December 1997 for 864 months. Okay, for textbook on AR1 GARCH 1 is obtained by this one. RT is, well, we have AR1 1 and then we have this log part. Okay, and then G looks like this. Okay, and then we have model checking, something like this. Okay, this is the interesting part. Therefore, the impact of negative shock over side of two standard deviation about 37.4 higher than that of positive shock of the same size. So it is very reasonable. We know negative shock has more impact, right? Another parameterization of GARCH model could possibly this way, where now gamma 1 denotes leverage effect. Okay. Now we can reanalyze IBM log returns in this way, right? And then we have a threshold GARCH or T-GARCH or GJL GARCH model. This is another very popular one. Actually, one of my favorite. My favorite model is actually GJL GARCH. T-GARCH SM or GJL SM model is defined as, well, RT is mu T AT and AT is this one. About this sigma T part, well, we have this one. Okay, we have this n part. Okay, this is the part. N is indicator variable. So we here in GJR model, we explicitly indicate whether shock is positive or negative. So where is negative, it has 1, otherwise it's 0. So here this gamma term captures asymmetry. Our expected gamma to be positive, so the prior negative returns have a higher impact on the volatility. Okay, and indeed is the case most of the data. The asymmetric power arch IPARCH model. This model was introduced by Dean Engel Granger as a general class of volatility model. So there is basic form of something like this. So it is very general. Epsilon is some distribution with mean 0 and then dispersion 1, and then we have this delta term. So we have delta moment, where delta is a non-negative real number. In particular, when delta is to give rise to T-GARCH model, when delta is 0 corresponds using log model. Okay, that's very powerful. Theoretically, one can use any power of delta to obtain a model. Okay. In practice, two things deserve further consideration. First, theta will also affect the specific mean equation I model for mu t. Second, it is hard to interpret this one except for some special values such as 0, 1, 2. Okay. So here we use fixed set delta equal to most popular case. Thus we can use a GARCH model to estimate T GARCH model. Okay, so this is example. Yeah, this is example. For the percentage root IBM stock, the estimated fitted GGR model is like this. So we have this one, asymmetric term like this one. Okay, where or which is actually negative. It is in line with our intuition, and all estimates are significant. And then log return, model for the log return as something like this. Okay. So the sample variance of the IBM log return is about 0.005, and the empirical 2.5 percentile of the data is about this one. If we use two quantities for sigma t minus square and a t minus replacement, then we have this one, plus minus 1. So it means that, well, negative volatility is negative variance about 2 times of positive volatility. Okay. In this particular case, the negative prior return has about 85% higher impact on the conditional variance. Very interesting result. Now we have another important class, which is stochastic volatility model.